Suppose if a line makes an angle alpha, beta, gamma with positive direction of x-axis, y-axis and z-axis, then L, M, N are called the direction cosines. Let A be the position vector of a given point A with respect to the origin. Therefore, vector OA is equal to A of the rectangular coordinate system. Let a line L passes through 2 points A, x1, y1, z1 and B, x2, y2, z2 whose position vectors are vector A and vector B. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty department of mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to take very important class, that is regarding three-dimensional geometry. So the revision of three-dimensional geometry, very important chapter and very easiest chapter for the point of examination. Now let us know regarding the weightage for this chapter. In this chapter you will get one mark question and two 2-marker questions and one 3-mark question and one 5-mark question. Totally the weightage for this is 13 marks. So 13 marks from this chapter you are going to get. Now let us move on to the first 1-mark questions. Now if a line makes an angle 90, 60 and 30 with positive directions of x, y and z axis respectively, find its direction cosines. Now suppose if a line makes an angle alpha, beta, gamma with positive direction of x-axis, y-axis and z-axis, then L, M, N are called the direction cosines. What are the direction cosines? So L is nothing but cos alpha, cos of alpha is L, M is equal to cos beta and N is equal to cos gamma. These are called as the direction cosines. So denoted as L, M, N. And further you know, if you add this L square plus M square plus N square is always equal to 1. Now here what is given? Alpha is given, alpha 90 degrees, beta is equal to 60 degrees and gamma is equal to 30 degrees. Very simple. L is equal to cos alpha, cos 90. What is cos 90? Sin 90. Sin 0, 0, sin 90 is 1, cos 90 it is 0. Then L, M is equal to cos beta. What is cos beta here? 60 degree. What is cos 60? Sin 60 root 3 by 2, cos 60 1 by 2. N is equal to cos gamma. What is this equal to? 30 degrees. What is cos 30? Sin 30 is of cos 30 root 3 by 2. So therefore, the direction cosines L, M, N are 0, 1 by 2, root 3 by 2. That's it. If you add L square plus M square plus N square is found to be 1. That's it. Right. This is how we are going to find the directions cosines. Sure questions. These type of questions are very important. You may expect definite this type of questions. Right. Now let us take a similar type problem. For one more, find the direction cosine of a line which makes equal angles with coordinate axis. Equal angles means alpha is equal to beta is equal to gamma. All the angles are equal. Now what is given? Cos alpha, cos beta, cos gamma are equal. Angles are equal here. That means we know this relation L square plus M square plus N square is equal to 1. Now what is L? You know L is equal to cos alpha, M is equal to cos beta and N is equal to cos gamma. Substitute here. L square, that is nothing but cos square alpha plus cos square beta plus cos square gamma is equal to 1. But it is given alpha is equal to beta is equal to gamma. This can be written as cos square alpha. Again beta is also equal to alpha, cos square alpha. Gamma is also equal to alpha. Cos square alpha plus cos square alpha plus cos square alpha. 3 cos square alpha is equal to 1. Only cos square alpha is equal to 1 by 3. Cos alpha is equal to plus or minus 1 by root 3. Cos alpha is equal to plus or minus 1 by root 3. Right. So what are the direction cosines? Therefore, the direction cosines are plus or minus 1 by root 3, plus or minus 1 by root 3, plus or minus 1 by root 3. These are the direction cosines. Very important. So that is the direction cosine of a line which makes equal angle with the coordinates axis is alpha is equal to beta is equal to gamma. Substitute here. cos square alpha, cos square beta plus cos square gamma is nothing but L square plus M square plus N square is equal to 1. Since alpha, beta, gamma are equal, cos square alpha plus cos square alpha plus cos square alpha, 3 cos square alpha. Cos square alpha is equal to 1 by 3 or cos alpha is equal to plus or minus 1 by 3. Therefore, the direction cosines are plus or minus 1 by root 3, 1 by root 3, 1 by root 3. Now, let us move on to the next problem. Find the direction cosines of x, y and z axis. So, in the examination they may ask, find the direction cosines of x axis or direction cosines of y axis, direction cosines of z axis. So, you may expect any one from this. Now, very important concept. Now, the direction cosines of x axis, direction cosines of x axis is 1, 0, 0. And similarly, the direction cosines of y axis, direction cosines of y axis is 0, 1, 0. And the direction cosines of z axis is 0, 0, 1. So, these are the direction cosines of x axis, y axis and z axis. In x axis, angle alpha is equal to 0, beta is equal to 90, gamma is also equal to 90. So, what is cos 0? Sin 0 is 0, cos 0 is 1. So, cos 90 is 0, 0. So, therefore, 1, 0, 0 is the direction cosines of x axis. Similarly, for direction cosines of y axis, 0, 1, 0. And z axis is 0, 0, 1. So, you may expect 1 from this. Now, move on to the next one. If a line has a direction ratios, so direction ratios are given, determine the direction cosines. So, what are direction ratios given? Here the direction ratios are 2, minus 1, minus 2. This is nothing but a, b, c. Now, just find out root of a square plus b square plus c square. So, this is equal to root of a square, 2 square is 4, 1 square is 1, again minus 2 square is 4. This is equal to root 9, square root of 9 is equal to 3. So, therefore, the direction cosines are 2 divided by 3, then again minus 1 divided by 3 and minus 2 divided by 3. These are the direction cosines. That's all. So, a by root of a square plus b square plus c square, b by root of a square plus b square plus c square, c divided by root of a square plus b. So, the direction cosines are these values, a divided by 3, minus 1 divided by 3 and minus 2 divided by, this is the direction cosine. That's it. Okay. Now, I hope you got an idea how to find the direction cosine when the angles are given and when the direction ratios are also given. Now, let us take very important 5 marks question. This is very important for 5 marks. So, you may expect this question for your 2023 examination. What is this? Equation of a line in space. Derive the equation of a line. So, to derive the equation of a line passing through a given point and parallel to a given vector. So, in the examination they may ask, derive the equation of a line passing through a given point and parallel to a given vector. Now, let us consider a line. Let A be the position vector of the given point A with respect to the origin. So, the position vector of A is vector OA is equal to vector A. Let A be the position vector of a given point A with respect to the origin. Therefore, vector OA is equal to A of the rectangular coordinate system. Let L be the line. This is the line. Let L is a line which passes through point A. A line L is a line which passes through the point A and parallel to the vector B. L is a line which passes through the point A and parallel to the given vector. Let P be any point on the line whose position vector is given by vector OP is equal to vector R. That's it. So, listen to me. Let A be the position vector of a point. Therefore, vector OA is equal to A. Let L is a line which passes through the point A and parallel to the vector B. Let P be any point on the line L whose position vector is vector OP is equal to vector R. Now, since this line, the line AP is parallel to vector B, the line AP is parallel to vector B if and only if vector AP is equal to lambda times vector B. If AP is equal to lambda times vector B, where lambda is some real number. Now, from this, vector AP is equal to lambda into vector B. Now, since we know what is vector AP is equal to vector OP minus vector OA, vector OP is vector R minus A. So this is vector R minus vector A is equal to lambda into vector B. Therefore, vector R is equal to lambda B. Transfer this minus A becomes plus A. Therefore, we can write vector R is equal to A plus lambda into vector B. This is the vector equation of a line. Very simple. So, if you do this much, you will get 2 marks, along with the figure 1 marks, 3 marks. So, since the line AP is parallel to the vector B, therefore, what is the condition? AP is equal to lambda into vector B, where lambda is some constant real number. That is, from AP is equal to lambda into B. Since what is AP vector? AP is equal to OP minus OA, that is vector R minus A. Vector R minus A is equal to lambda into B. Transfer this minus A to right hand side, minus A becomes plus A, lambda B plus C is equal to R. Therefore, R is equal to A plus lambda B. So, R is equal to A plus lambda B is the vector equation of the line. Now, let us move on to the Cartesian form. Now, the second one, the Cartesian form. From vector form, from vector equation, vector R is equal to A plus lambda into vector B. Now, what is vector R here? Since vector R is equal to position vector of P, therefore, vector OP is equal to vector R, that's equal to xi plus yj plus zk, and vector A is nothing but position vector of the point A, that is nothing but x1i plus y1j plus z1k, and the vector B is nothing but vector A into I plus B into j plus C into k. Now, substitute here. Now, from vector equation, vector R is equal to A plus lambda into vector B. Substitute the value of R. What is R? Vector xi plus yj plus zk is equal to vector A. A is equal to x1 into I, y1 into j plus z1 into vector k. This is x1 plus lambda into vector B. What is vector B? Vector B is nothing but A into I plus B into j plus C into k. A, B, C are the direction ratios. Now, simplify this. Transfer this to the left hand side. Then this becomes xi plus yj plus zk. If you transfer this, becomes minus x1i minus y1j minus z1k is equal to lambda into ai plus lambda into bj plus lambda into 2 times c times k vector. Now, subtract this. So, x minus x1 into I, subtraction of vectors, coefficients of I, j, k, y minus y1 into j plus z minus z1 into k is equal to, this is as it is, lambda A into I, lambda B into j plus lambda C into k. Now, equating the coefficients of I, j, k, equating the coefficients of I, j and k. What we will get? X minus x1 is equal to lambda A, y minus y1 is equal to lambda b, and similarly coefficient of k is z minus z1 is equal to lambda into c. Simplify this, that is x minus x1 by a is equal to lambda, y minus y1 by b is equal to lambda, and z minus z1 divided by c is equal to lambda. So, therefore, the equation is x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. This is the Cartesian equation, of line. That's it. So, this is how we are going to derive for 5 marks. Very important sure question for the point of examination. Now, let us take few problems based on this. Find the vector and Cartesian equation of the line through the point 5, 2, minus 4 and which is parallel to the given vector. Very simple. See here, point is given. This is the point and parallel to the vector. That means this is point A and that is point B. Given A. What is A is equal to 5 comma 2 comma minus 4. So therefore this is nothing but vector A. The position vector of A. Position vector of A is equal to vector A is equal to 5i plus 2j minus 4k. And the vector B is given. Vector B is equal to 3i plus 2j minus 8k. This is given, right? Now just write the vector equation. What is the vector equation? Vector equation is vector R is equal to A plus lambda into vector B. Vector R is xi plus yj plus zk is equal to, what is vector A? Vector A is 5i plus 2j minus 4k plus lambda into vector B. What is vector B? Vector B is 3i plus 2j, 3i plus 2j minus 8k. That's it. This is the vector equation. So this is for 2 marks. If you write this much, you will get 1 mark. Vector equation xi plus yj plus zk is equal to 5i plus 2j minus 4k plus lambda into 3i plus 2j minus 8k. Now the Cartesian equation. Cartesian equation is, what is the formula? X minus x1 by a, y minus y1 by b, z minus z1 by c. So this is x1, y1, z1. This is x1, y1 and z1. A, b, c. A is 3, b is 2 and c is equal to minus 8. So let us write here x minus x1. x1 is 5 divided by a is 3. Y minus, what is y1? y1 is 2 divided by b is 2. Z minus z1 is minus 4. Minus into minus plus 4 divided by minus 8. This is the Cartesian equation of the line. That's it. Hope you followed. So 2 marks. Just write the vector equation and the Cartesian equation. You will get 2 marks. Now let us move on to the next one. So very important next derivation. So equation of a line passing through 2 given points. So this is also very important for 5 marks. Derive the equation of a line in space passing through 2 given points both in vector and Cartesian form. So the equation of a line which passes through 2 points and both in vector and Cartesian form. Now let us come to the proof. Let us consider the 2 vectors. Let A and B be the position vector of 2 points A x1, y1, z1 and B x2, y2, z2 respectively, which lies on a line L. So this is a line L. Let us consider this is the line L. Let A x1, y1, z1 be any point and x2, y2, z2 be the other point. That means let a line L passes through the 2 points A x1, y1, z1 and B x2, y2, z2. Therefore, the position vector of A is vector OA is equal to vector A, that's equal to x1i plus y1j plus z1k. Similarly, the position vector of the B is vector OB is equal to vector B, that's equal to x2i plus y2j plus z2k. Let P, x, y, z be any point on the line whose position vector is vector OP is equal to xi, that is vector R is equal to xi plus yj plus zk. Now let us represent this as vector A and this is vector B and this is vector R. Right, A, B, C. A and B are any 2 vectors. So we are going to find the equation of a line which passes through these 2 points A x1, y1, z and B x2, y2, z2. So let R be the position vector of an arbitrary point P, x, y, z. Let P is a point on the line if and only if vector AP is equal to R minus A and AB, B minus A are collinear. That means if AB and AP vector, AP and AB are collinear. AP and AB are collinear. So AP and AB are collinear means vector AP is equal to lambda times vector AB. Right. Collinear means lambda times vector AB. What is AP? So vector AP is equal to R minus A. Vector R minus A is equal to lambda into what is vector AB? Vector AB is nothing but vector B minus A. Transfer this. R is equal to lambda into B minus A plus minus A becomes plus A. So therefore vector R is equal to, put it in order, A plus lambda into B minus A is the vector equation. That's it. This is the vector equation. Very simple concept. See, Let a line L passes through 2 points A, x1, y1, z1 and B, x2, y2, z2 whose position vectors are vector A and vector B. Let P, x, y, z be any point on the line whose position vector is vector OP is equal to R. Since APB lies on the same line, that is collinear, so let P is the position, yes, the P is a point on the line if and only if vector AP, this vector AP and AB are collinear. Vector AP and AB, A to P and AB are collinear. Collinear means AP is equal to lambda times vector AB. What is AP? We know AP is equal to vector R minus A, lambda into what is AB? Vector B minus A, OB minus OA. So, just transfer this, you will get R is equal to A plus lambda into B minus A. This is very easiest method. Now, move on to the Cartesian form. So, in the Cartesian form, just substitute what is R? Xi plus Yj plus Zk. What is A? X1i, Y1j, Z1k. What is B minus A? X2 minus X1, Y2 minus Y1, Z2 minus Z1. That's it. Now, so vector Cartesian form. Now, from vector equation, vector R is equal to A plus lambda into B minus A. Now, what we have vector R? Vector R is Xi plus Yj plus Zk, and vector A is nothing but X1i plus Y1j plus Z1 into k. Vector B is equal to X2i plus Y2j plus Z2k. Now, just find out B minus A first. Now, vector B minus A, subtract this B minus A. If you subtract this, what you will get? X2 minus X1 into I plus Y2 minus Y1 into J plus Z2 minus Z1 into K. Now, substitute here. So, this equation becomes Xi plus Yj plus Zk is equal to A. What is A? X1i plus Y1j plus Z1k plus lambda into this B minus A vector is X2 minus X1 into I plus Y2 minus Y1 into J plus Z2 minus Z1 into K. That's it. See here, vector R, vector A, and lambda into B minus A is X2 minus X1 plus Y2 minus Y1 plus Z2 minus Y. Now, transfer this to the left hand side. What happens? You will get Xi plus Yj plus Zk. If you transfer, it becomes minus X1i minus Y1j minus Z1k is equal to multiply by lambda into X2 minus X1i plus lambda into Y2 minus Y1j plus lambda into Z2 minus Z1k. Now, subtract this. If you subtract, what we will get? X minus X1, Y minus Y1, Z minus Z1. So, X minus X1 into I plus Y minus Y1 into J plus Z minus Z1 into K, Z minus Z1 into K is equal to, left hand side is same, that is lambda into X2 minus X1 into I plus lambda into Y2 minus Y1 into J plus lambda into Z2 minus Z1 into K. Now, equating the coefficients, of I, J and K. What we will get? X minus X1 is equal to lambda into X2 minus X1, Y minus Y1 is equal to lambda into Y2 minus Y1, and Z minus Z1 is equal to lambda into Z2 minus Z1. Now, bring this to the denominator. So, what happens? X minus X1 by X2 minus X1 is equal to lambda, Y minus Y1 divided by Y2 minus Y1 is also equal to lambda, Z minus Z1 by Z2 minus Z1 is also equal to lambda. Now, put it in a form. Therefore, the required equation is X minus X1 by X2 minus X1 is equal to Y minus Y1 by Y2 minus Y1 is equal to Z minus Z1 by Z2 minus Z1. This is the Cartesian equation. This is the Cartesian equation of the line. Very simple. So the vector equation is vector r is equal to a plus lambda into v minus a, whereas the Cartesian equation is x minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1, z minus z1 by z2 minus z1. That's it. Hope you followed. Very important. So you may expect either first or second derivation for 5 marks. Now, based on this, let us take few problems. Now, find the vector and Cartesian equation of a line passing through the points. So, what are the points given? Given vector A is equal to position vector minus I plus 0j plus 2k. Vector B is equal to 3I plus 4j plus 6k. Right. Now, write first vector equation. Vector equation, vector r is equal to a plus lambda into b minus a vector. Vector r is nothing but xi plus yj plus zk is equal to vector a. A is minus I plus 0j plus 2k plus lambda into, subtract this. If we subtract, what will get? 3i. Yes, 3i minus into minus, I will write here b minus a. B minus a can be written as vector 3i plus 4j plus 6k multiply by negative sign, minus and minus becomes plus I minus 0j minus 2k. What is this equal to? 3 plus 1 is 4i, 4j, j term is not there, 4j, and 6k minus 2k is plus 4k. So, this is lambda into 4i plus 4 times j plus 4 times k. So, this is the vector equation. Now, Cartesian equation, these are the points. Minus 1 comma 0 comma 2, this is x1, y1, z1. Another point 3 comma 4 comma 6. This is x2, y2, z2. Now, what is the Cartesian equation? Cartesian equation is x minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1 is equal to z minus z1 by z2 minus z1. X minus, what is x1? x1 is minus 1, minus into minus plus divided by 3 minus into minus is 4, 3 plus 1 is 4. Y minus y1, y1 is 0 divided by y2, 4 minus 0 is equal to 4. Z minus, what is z1? Minus 2 divided by z2 minus z1, 6 minus 2 is equal to 4. So, x plus 1 by 4, y by 4, z minus 2 divided by 4 is the Cartesian equation of the line. That's it. Hope you followed. Right. Now, move on to the next problem. The Cartesian equation of a line, this is given, and find the vector equation. Now, very simple. What is given? This is given. Compare this with x minus x1 by a, y minus y1 by b, z minus z1 by c. So, a comma b comma c, the direction ratios are 2 comma 4 comma 2. Then x1 comma y1 comma z1, x1 comma y1 comma z1 is minus 3 comma 5 comma minus 6. So, this is vector b, this is vector b, and this is vector a. What is the vector equation? The vector equation is vector r is equal to a plus lambda into vector b. Vector equation r, what is r? xi plus yj plus zk is equal to vector a. What is vector a? This is vector a, that is minus 3i plus 5j minus 6k plus lambda into vector b. What is vector b? 2i plus 4j plus 2k. This is the vector equation. That's it. So, if you do this much, you will get 2 marks. Okay. Now, next, angle between the lines. So, this is very, very important. You may expect this question for the point of examination. Find the angle between the pair of lines. What are the lines given? R is equal to 3i plus 2j minus 4k plus lambda into I plus 2j plus 2k, and R is equal to 5i minus 2j plus mu into 3i plus 2j plus 6k. Now, comparing with vector R is equal to a1 plus lambda into vector b1. So, therefore, vector a1 is equal to 3i plus 2j minus 4k, and vector b1 is equal to I plus 2j plus 2k. Similarly, compare this with vector r is equal to vector a2 plus mu into vector b2. So, vector a2 is equal to 5i minus 2j, vector b2 is equal to 3i plus 2j plus 6k. These are the given conditions. Now, what is the formula for angle between the vectors? The angle between the vectors is given by cos theta is equal to vector b1 dot b2 divided by length of b1 into length of b2 mod. That's it. Angle of intersection between these two lines is given by cos theta is equal to mod of b1 dot b2 divided by length of b1 into length of b2. Now, just simplify this. This is equal to b1 b2. Write down the dot product for these two. Modulus of 1 into 3 plus 2 into 2 2 into 2 plus 2 into 6 divided by length of b1. 1 square is 1 plus 2 square is 4 plus 2 square is 4. Similarly, length of b2. 3 square is 9 plus 2 square is 4 plus 6 square is 36. Now, what is this equal to? Cos theta is equal to mod of 3 ones are 3 plus 2 twos are 4 plus 6 twos are 12 divided by square root of 9 into square root of 49. What is this equal to? That's equal to 4 plus 3, 7 plus 12 is 19 divided by 3 into 7. So, cos theta is equal to 19 divided by 7 3s are 21, 19 by 21, or theta is equal to cos inverse, theta is equal to cos inverse of 19 divided by 21. So, the angle of intersection between this is given by theta is equal to cos inverse of 19 by 21. That's it. This is the angle. Very important, right? Now, move on to the next one. Find the angle between the pair of lines. So, this is nothing but A1, B1, C1. This is A2, B2, C2. Consider these values, that's all. So, angle of intersection between this is cos theta is equal to B1 dot B2 divided by length of B1 and B2 vectors. So, what are B1 and B2? Vector B1 is equal to 3i plus 5j plus 4k, and another vector B2 is equal to I plus j plus 2k. Simplify this. This is equal to 3 into 1 plus 3, yes, 3 into 1 plus 5 into 1, 5 into 1 plus 4 into 2, that's it, divided by the length of 3 square is 9 plus 5 square is 25 plus 4 square is 16, and second part 1 square is 1 plus 1 plus 4, that's it. So, simplify this. Cos theta is equal to mod of 3 ones are 3 plus 5 ones are 5 plus 4 twos are 8. This is into 4 into, this is 4 into, divided by, so 25 plus 25, this is 50 into 6. So, this can be written as cos theta is equal to 16 divided by square root of 50. 50 can be written as 5 root 2 into root 6 can be written as root 2 into root 3. Now, simplify this. If you simplify this, this is 16 divided by 5 into root 2 into root 2 is 2 into root 3. So, this gets cancelled. This is equal to 8 divided by 5 root 3. Cos theta is equal to 8 divided by 5 root 3. If you want, you can rationalize and simplify. That's it. This is the simplified answer. If you want, you can rationalize and simplify. Now, move on to the next, shortest distance between the two lines. Now, just observe carefully. This is also a very important problem for 3 marks. Now, find the shortest distance between the lines. Observe carefully. I plus 2j minus 4k plus lambda into I plus 2j plus k, 3i plus 3j minus 5k plus mu into I plus 2j plus. So, B1 and B2 are same. That means they are parallel lines. So, these are parallel lines. So, the shortest distance between these two parallel lines is given by the distance d is equal to, yes, vector B2 cross A2 minus A1 mod divided by length of vector B. That's it. So, modulus of, that is the length of Vector b cross a2 minus a1 divided by length of b under mod will give the distance between these two parallel lines. Now, what is a1 here? This is a1. a1 is vector I plus 2j minus 4k, and vector b is same. This is I plus 2j plus k, and vector a2 is equal to 3I plus 3j minus 5k. Now, just find out a2 minus a1 first. a2 minus a1, subtract this. 3I minus I is 2I from this. 3j minus 2j is plus j. Again, minus 5 minus into minus plus, this is equal to minus 5. Now, just write down the cross product b cross a2 minus a1 vector is nothing but determinant I, j and k. What is the cross product? So, vector b is 1, 2, 1, 1, 2, 1, and a2 minus a1 is 2, 1, minus 1. Simplify this. I into minus 2 minus 1 minus j into, this is gone, minus 1 minus 2 plus k into 1 1s are 1 minus 2 2s are 4. So, this is nothing but minus 3I minus into minus plus 3j minus 3k. This is vector b cross a2 minus a1. Substitute here. Now, the magnitude of this, now the length of b cross a2 minus a1 vector is equal to square root of 3 square is 9 plus 9 plus 9, that is nothing but 9 into 3, that is nothing but 3 root 3. 9 3s are 27. Now therefore, what is the distance formula? Find out length of b. Now, length of b is equal to square root of b, 1 plus 2 plus 4, that is 1 plus 4 plus 1 root 6. Now, therefore, the distance d is equal to b cross a2 minus a1 length, that is root 3 root 3 divided by root 6. Simplify this. 3 root 2 divided by root 3 into root 2. Root 2 gets cancelled. 3 by root 3. This can also be written as root 3 into root 3 divided by root 3. One root 3 gets cancelled. So, the distance d is equal to root 3. That's it. Right. So, the distance d is equal to root 3. That's it. Now, move on to the next one. Next concept is the problems based on the plane. Find the vector equation of the plane which is at a distance of 6 by root 29 from the origin, and its normal vector from the origin is 2i minus 3j plus 4. Normal vector and the distance is given. Very simple. What is given? The distance d is equal to 6 by root 29 and the normal vector n is equal to 2i minus 3j plus 4k cap. What is the equation of the plane in the normal form? Equation of the plane is very simple. Equation of plane is r dot n is equal to d, or vector r dot n cap is equal to d. Now, here just find out the n cap. N cap is equal to vector n divided by its own length. So, that is vector 2i minus 3j plus 4k divided by length of this vector. 2 square is 4 plus 3 square is 9, 4 square is 16. Substitute here. This is vector r dot n cap. N cap is nothing but vector 2i minus 3j plus 4 times vector 4 cap divided by 16 plus 4, 16 plus 4 is 20 plus 9 is root 29. Root 29 times, what is d? D is equal to given 6 by root 29. Now, just cancel the denominator. If you divide by 29 root 29, what you will get? So, therefore, vector r dot 2i minus 3j plus 4k cap is equal to 6 is the vector equation. That's it. Now, move on to the next simple problem. Find the equation of the plane with intercepts 2, 3 and 4 on x, y and z axis respectively. So, the equation of the plane is x by a plus y by b plus z by c is equal to 1. What are the points given? A intercepts, x intercept a is 2, y intercept b is equal to 3 and z intercept c is equal to 4. So, the equation is x by 2 plus y by 3 plus z by 4 is equal to 1 is the equation. That's it. Okay. Find the intercepts cuts off by the plane 2x plus y minus z is equal to 5. So, what is given? 2x plus y minus z is equal to 5. Divide by 5 on both sides. 2x by 5, y by 5 minus z by 5 is equal to 5 by 5. So, this is divide it. X divided by 5 by 2 plus y by 5, this is plus z divided by minus 5 is equal to 1. So, a is equal to 5 by 2, b is equal to 5, c is equal to minus 5. So, therefore, the intercepts x is equal x intercept is 5 by 2, y intercept is 5, z intercept is c is equal to minus 5. That's it. So, in the examination they may ask the sum of the intercept a plus b plus c, just add it, it will give the answer. Next, find the distance of the point 2 comma 5 comma minus 3 from the plane r dot 6i minus 3j plus 2k is equal to 4. Now, what is given here? Vector, yes, the point a is given. A is equal to 2i plus 5j minus 3k, and r dot n, vector n is given. This is r dot n is equal to d, vector r dot n cap is equal to d. Now, what is n here? Vector n is equal to, that is 6i minus 3j plus 2k, that's it. Okay. And what is d? D is equal to 4. So, what is the formula? The distance d is equal to, capital D is equal to a dot n minus d, vector a dot n minus d divided by length of vector n, that's it. Okay. Now, simplify this. Now, find out vector a dot n, dot product of a and n. A dot n is equal to 2 into 6 plus 5 into minus 3 plus minus 3 into 2. So, 6 2s are 12, 5 3s are 15, 3 2s are 6. So, that is nothing but 12 minus 21, that is equal to minus 7. So, this is equal to minus 7 minus what is d? D is equal to 4 divided by, now find out the value of n cap, just sorry, find out the value of magnitude of n. Magnitude of n, 6 6 are 36 plus 3 3s are 9 plus 2 2s are 4. So, that is nothing but 49. Square of 49 is 7. Substitute here, divided by 7. So, the distance d is equal to minus 13 by 7. So, therefore, the distance is equal to 13 by 7 is the distance, that's it. So, this is the distance from a point 2 5 minus 3 to the plane, that's it. This is how we are going to find. This is also very important for 3 marks. So, hope you followed. Just practice. Definitely you will get few questions from this for the point of examination. So, that's all regarding today's session. Let us meet with different concept in the next session. Thank you. Thank you very much.